All right, friends. For our second presentation of this afternoon, I would like to present Vadim Opolski, Senior Data Engineer at Logsoft, who will tackle how AI can optimize query execution plans, making them faster and more cost-efficient. Whether it's Hadoop, Spark, or Hive, Vadim will show us how smarter tools can transform big data. Vadim,
Hello.
this is yours.
Hello.
Thank you very much.
Yeah. Hello, ladies and gentlemen. So my name is Vadim Opolski, and I'm a global data chapter lead and a senior data engineer at Logsoft DXC. So I'm not a manager. As most of you, I write code every day. So in the past, I contributed the open source project Apache Ignite. So this is the distributed in-memory grid. I joined Logsoft in 2019, and so built system with the Apache Spark, Flink, Kafka, Hive, Hadoop, and other distributed big platforms for such clients as a largest provider of multi-channel satellite television in the US and largest investment bank in Germany. Yeah, so my talk about the migration from on-premises to cloud platforms for data processing projects. And so many years, the DXC clients use the different on-premises platforms like MS SQL Server, Apache Spark, Hive, Hadoop, Vertica, Oracle, and other data processing and storages system. So the DXC Logsoft has a different clients from different area, for instance, automotive, bank, and capital industries. Yeah, so all of them has the one common thread. They migrate to clouds from on-premises Hadoop system, Oracle, Vertica, to such data processing system as Azure Synapse Analytics, HD Insight, also from Azure, the Dataproc, Google Cloud Platforms, Databricks, Amazon Elastic MapReduce, and Snowflake. What is the main benefits of migrating from on-prem to the cloud? So let's talk about the optimization and the process of querying the data. So here you can see the classic scheme of optimization, or what happened under the hood when some user submit the query. And between the query and receiving the result, we can see something like this: the parsing plan, the optimizing the query plan, then going to low level execution level. In case of Apache Spark, this is the RDD, and execution. So after this, we can see the result table, and so the time of this process is very important. Why? Because nobody, of the booking clients will wait the 5 or 10 minutes while the booking return the set of the hotels where we can go in the vacation. So this time, the time where we request the data and receive the results, it's very important. If we take a look into the details, what happened under the hood between the querying and receiving the result, we can see the analysis step, logical optimization step, the physical planning and generating the several physical plan, and then using the cost model, selecting the best physical plan or the cheapest physical plan. This cheapest physical plan will be implemented in the low-level code and running. Could you please take a look to this optimization step, which called the cost-based optimization. The cost-based optimization has the history, and the history started in 1917 when the IBM created an experimental database called the System R, and it was one of the first to use the cost-based optimization, a way for the system to pick the best way to run a query by estimating a cost-different approach. So then, when SQL became popular in the late of 1917s and 1918s, the database need the better ways to handle complex query. So cost model became important to make sure the system run queries efficiently. So also we have the two different way of optimization, the rule-based optimization and the cost-based optimization. So rule-based optimization was before cost optimization, and in the cost-based optimization, in the 1990s, databases like Oracle and DB2 started using detailed information about the tables and data set, like the size of the data distribution. And this data helped cost models make better decisions when choosing the query plans. So this cost optimization can help to select the best join type, like a nested loop, like a hash join, or merge join. So the cost-based optimization under the hood use the dynamic programming for optimization, and systems like Postgres and Oracle use the dynamic programming in the query optimizer. So in the 1990s and 2000s, the database started using the materialized view, which store pre-computed result of expensive queries. So cost models were updated to consider the using these pre-computed results. In the 2000s, the parallel query optimization, so the computers started to use a multi-course system. Also in the beginning of the 2000s, you can see the Apache Spark, which works on the several machines with the limited resources. And so the cost-based optimization also adopted to this parallel computation. So the parallel query optimizations. The next step, which is very interesting, so if you work with the Apache Spark, you can remember the Spark 3. Starting the Spark 3.0 and Oracle 12. There is another type, another revolution in the cost-based optimization. This is the adaptive query optimization, when during the execution the physical plan can be changed, and it also increased the speed of the query, which is very important for data processing. And there is the question, so what is the next step? What is the next step? Yeah, let's consider the AI-driven cost-based optimization. So what is it and what we can improve in the cost-based optimization? If we take a look at this scheme, so here you can see the several physical plans generated by cost-based optimization. So each plan split it to the sum action, and each action can be evaluated with the sum cost. Then we can see the total cost, and in the end, the cost-based model select the cheapest physical plan. And that's why we have the very quick query optimization. Yeah, so there is a question, how the evaluation can be done? And many years, the companies use the heuristic. So this is the some rules mixed with the statistic, which allows you to evaluate the, for instance, scan cost, fetch cost, join cost, and that's it. And right now, the cloud platforms and vendors during the last several years, 5 or 6, they collected the statistic of cost-based optimization. And based on this statistic, yeah, so this is the depersonalized, they built a model. And the machine learning model allows to evaluate better evaluate each physical plan. And so that's why the data processing platforms can select the best plan, the best execution plan, which runs quicker. Yeah, and the problem that for open source system, the open source system cannot give the access to the data statistic during the several years. So this is the billions of the executed query. And there is a question, how can open source project compete with the vendor platforms if it's possible to collect data for training the model? Yeah, and so let me tell what we already do for the clients, and yeah. So we can create some auto configurator for example, for Apache Spark. If you work with the Apache Spark or maybe the Oracle database system, you know that usually it has the huge amount of the different configuration when we put before the starting the job. Like the cost-based optimization. So by default is disabled, but we can enable it. And how we can know so what to do with some particular config, enable it or disabled. Or for instance, use the commercial platforms with the cost-based optimization with AI, because there is no AI cost-based optimizations in the open source project. Yeah, so the answer for this question can give the expert in Postgres tuning, in Oracle, in Spark as well. Yeah, but also, so what we can do, we can create some tool which allows automatically, based on some small amount of the statistic, predict do we need to enable some optimization config or not. And yeah, so when it can be useful in any data processing project, like we have the source, Kafka, Spark, Amazon data lakes. We have some data lakes with the several layers, bronze, silver, and gold, and we have the BI system, or maybe some machine learning and AI. Yeah, so any repeated queries, the time-consuming queries over 10 minutes or bigger, and in case of the Apache Spark, any high-level Spark API, excluding the low-level API like the RDD. Yeah, so what could be an example of the architecture of this tool? So in the in the left side, you can see the Spark cluster, and we can run the Spark job using the Spark submit code. And usually, the Spark submit code has the several Spark optimization configure, like the Spark SQL CBO enabled or disabled, join reorder, and star scheme detection. Yeah, so we can run with this Spark submit. So this driver, Apache Spark driver, received this Spark submit, received the query, which the user usually sent also together with the Spark submit, parse the query, then the special listener can send the statistic information to the outer configurator, so to the feature store. Feature store will receive this statistic about the query, or maybe also about the data set and the configuration we set in the Spark submit. Okay, and then use the collected statistic. We can train the model, which the next iteration, when we run the query again, yeah, so it offers the best set of the Spark optimization configs based on the previous statistic. Okay, and so after the several hundred iteration, so the model will predict the time very good, and we can select the execution time, and we can select just the set of optimization which give us the minimal time of the execution. So which statistic we can collect? So any query can be parsed by driver, and driver usually has the information about how many joins, how many columns in the joins, how many join keys, then filters, sorting operation, window operation, and that's it. Plus the statistic of the data set, the amount of the rows, formats, the type of the query, and that's it. And also the set of the optimization in the Spark submit. Yeah, so a lot of the queries, guys, you can find in the TPC-DS. This is the benchmark for every database like Oracle, Spark, and so on. It has the more than 100 complicated queries which can be used if you want, for instance, also to implement something similar and train the models which allows to help configure the Spark job. Yeah, so also you can find here the scalable data set which built with the Snowflake or Star scheme. So this is the open source. I put here the QR code. You can photo it and find the all data sets, queries, and the instruction how to deploy it to the Hadoop and play yeah, also in the README file. Yeah, so which Spark configs can we use as a features for the training model? So here you can see the only one optimization, the cost-based optimization enabled or disabled. And yeah, so join reorder, star schema detection, and many other configs, but I recommend to maybe join, to start with the only one optimization. Because it also can help not to maybe increase the speed of the query, but monitor the daily workload. And if something happened, for instance, the data scale, or maybe there's some business logic in the code can be changed by the data engineer. So you can automatically detect the highest query execution time and automatically enable the special optimization config, yeah, which allows to maybe save the daily workload without any, yeah. So the one more idea about the which model we can use to predict the time in the cost-based optimization. So here you can see the huge amount of the model, and we can use from the one side the such models like a random forest, XGBoost, which allows us to predict only the cost, only the time of the execution. But also, right now, the AI model, GNN model, is very popular, and using the AI model can not only predict the time, but also explain why the special set of the optimization give us the minimal time. And it can be very useful, for instance, for data engineers' daily work, because they can receive not only the best set of the configs with the minimal time, and also the explanation of it. Yeah, and also, guys, so this story right now inside the company, but I invite all of you maybe to some open source project which allows us together to do some experiments with the configs and collect the data set, because it's very important to collect the data set with the some statistic, which, yeah, so the biggest data set can allow us train the very good model. But in the local project and in the local in the small big data project, it's impossible. It's impossible to competitive with the vendor clouds, which has the huge amount of this statistic and can build the can train the model. But anyway, the open source community can try to do it, and maybe in the several years collect this data set, and also the such pre-trained the open source model, which allows to automatically configure the Apache Spark or maybe other data processing system like Flink with the previous presentation. Yeah, so Thank you so much for listening, for invitation.
Thank you very much, Vadim. All right, friends, do we have questions? Do you need coffee? Yeah? Question over there, and then coffee.
Hi, thank you for your presentation. This may sound like an unfair question, but I want you to give me like a rough estimate. How much do you think the performance boost would you get with like good model?
Yes, so the main goal of this to find the set of the configuration which allows to increase the query, I don't know, maybe more than 2 or 3 times. Because in the some of the presentation from Databricks, the Databricks presented the AI-driven optimization, and it allows to increase the sum query 25 times. Yeah, so the main goal is to find the queries from the one side which can be optimized in such amount of the in such way, and the set of the configuration which allows to do it. And then, so it will be very, very nice. Because, you know, if we increase the query in 30% or 30%, so today it's okay, but tomorrow we change the environment, we change the logic, and so it will, like the guy from Databricks told, it's very tricky. And from the delivery, the main benefits, it's not the optimization, but it's some alerting system which allows to detect some problems on the production and inform, and maybe in the same night, the change configuration and recover and save the computation. Yeah.
This is very interesting. Thank you.
Yeah, thank you for the question. Very, very nice question. Thank you, guys.
Thank you very much. Thank you very much, Vadim, for sharing your insights. This is a token of appreciation.
Oh, thank you.